Okay, we have a squad within our DevOps and the developer experience team. We're 3 people, actually 2.5 people, because one guy is also a manager. But our our mission is to build this infrastructure that spans over bare metal and Amazon, and our goal is to provide a seamless experience for the application teams so that they can run their applications in wherever they want, depending on how much they are costing it. My name is Nilanjan Roy, and I am a staff DevOps engineer. And with me today is Erik and Ruiyang, who will be handling things from now.
Yes, hello, I'm Erik Karsten. I'm also a DevOps engineer and working in the H Cloud squad at the moment.
Yeah, hello, I'm Ruiyang Ding. I'm the interim engineering manager for the developer tooling team. But at the same time, I'm also a DevOps engineer working for the hybrid cloud squad. And today, let's talk about my half, which only involved into hardcore technical implementation. So I'll be only talk about a cloud today. So let me actually take over the presentation and start with background and the challenges. So basically, I'll introducing you guys some background on why we have this hybrid cloud setup, and also the initial challenges we are facing that leads us to do this AWS raw service account approach. All right, as you might all know, or some of you might know if you have been to our previous presentations, in Smartly we do Kubernetes the hard way. So why we call it the hard way? Because first, of course, there's a lot of hardware being involved in doing this, because we're running most of our infrastructure in the baremetal cluster that's hosted by this company called Heisner. And the second is that it's a lot of hard work to keep the on-prem infra compared with normal cloud infrastructure. And the last part is that it requires the hardcore knowledge for the whole Kubernetes ecosystem, not only about how do you deploy something to Kubernetes, but it's also about how Kubernetes works from the very bottom layer. All right, I think Thomas might already show you some of the numbers, and we can show you the number again here. So basically, as you can see from these numbers, we are not only doing the Kubernetes in a hard way, we're also doing things in a much big scale. So that's also the reason why we initially decided to do Kubernetes in the hard way, because as you can see, the big numbers means big bill from the cloud providers. And by doing things on bare metal, we can obviously save a lot of cost for the company. However, you might ask, what's the reason for us to go for cloud, right? We seem to have very good expertise on working on the bare metal infrastructure, and everything seems going well. But why do you bother to go to cloud? Well, there's 3 main reasons. The first reason is scalability, because as you all know, we are working on this social media ads. It means like we will get a lot of seasonal traffic. You know, like during the Christmas sale, during Black Friday, the traffic will go up. You know, during evening, the traffic might go down. And the bare metal infrastructure doesn't really allow us to scale the whole infrastructure, but instead, it's always a fixed capacities. But with the cloud infrastructure, it's much easier for us to scale the things up and down according to the demand. That's the first point. Second point is reliability. I can just give an example. In a EKS cluster, if a node goes down, the AWS will automatically bring a new node back into the node pool. So basically, the cluster will keep the same capacity without human intervention. However, in Heisner, it happens very often that because every Kubernetes node is an actual server, right? If it's a hardware, it's always prone to having error. And when a server goes down because of different reasons, we need like a manual intervention, either to contact Heisner to replace the server, or we try to reboot the server ourselves, or we order a new server and then provision everything Kubernetes related in that server and connect it to our infra. So it's a lot of work. And of course, the customer is not very happy if our Kubernetes cluster is impacted by whatever reason. And the last one is agility. So in the modern company, everything needs to be moved very fast. We have new services created every day. We have demand for new cluster. We also need to keep our Kubernetes cluster up to date. And it's much easier to do that in the AWS environment. So as Papa just mentioned that, we want to build this capability to be able to run things in AWS because of all these reasons, and we will choose the workload accordingly and put them into AWS. But first, we need to build the capability to have things in AWS. All right, so let's talk about initial challenges on running this hybrid setup. So this might be a very typical hybrid setup in our system. You have the Kubernetes cluster, you have the pod, the services running the Hetzner-based servers. However, you might need to, the service running the Hetzner cluster need to gain access to some AWS resources. Okay, so what is the easiest way? Let's say if you want to move things fast, right? What's the easiest way to give something outside of AWS certain access to AWS? You create a user, and you create the access key and access secret. Then you put this access key somewhere in the Kubernetes, maybe as a kube secret, and then voila, you have access to AWS from Kubernetes. Sounds easy, right? However, some of you might know, 2024 is a year of cybersecurity. There's just so many security incidents that at any time, there might be a master thief, right, coming from your internet cable, and they just steal the key. And then they might do something malicious with the key they stolen. So, how do you prevent this? You can go to every developer team and tell them, hey, the key might get stolen because we have so many security incidents, we have so many supply chain attacks. Please make sure you rotate your key every 30 days, right? However, as we all know, if you're working in a big organization as a platform engineer, the biggest challenge is try to make all the development team do something and do something right. So it's ended up to be a very big challenge for us to try to push everybody to actually rotate the key in time, and then we end up having to do it ourselves, right? Then it took us a lot of time to develop new exciting things that we're gonna just present in the next few minutes. Okay, so the question is is there a way to get out from this situation? So we're gonna be introducing the IAM role for service account. So as you can see from the title, basically it means that a service account gets tied to an IAM role in the AWS. And without access key, without access secret everywhere, and with the magic setup we're gonna present in the next slides, all the pod that has this service account attached will be able to assume this AWS role and get access in need in AWS. So I'll give my microphone to Erik next, and he will talk about the actual architecture and implementations. Thank you very much.
Thanks, Ruiyang. Now that we've covered the context, I'll walk you through how the authentication flow and the high-level architecture of the thing works, and then also how we've configured the different components in between there. So here's a diagram of the authentication flow, and it all starts with us generating a key pair. So just your normal RSA private key, public key. Then you put the public key into an S3 bucket in AWS, which we'll be using as an OIDC provider. Then we set the private key onto the control plane. So let's take a look at how we actually set it there. So here's a pod spec. It's for running the Kube API server. And we store the private key on the master node. We then we mount it to the pod, and then we set some command line flags to make sure that Kubernetes always signs the service account tokens with this specific private key. Along with that, we set a couple other options to set some settings in the token, so the issuer and audience. Now let's move on to the actual service namespace. So we have this service Wanda that like our developers would manage, and it has two different resources. There's a service account and a pod. On the service account, there is an annotation that specifies what role it should assume on AWS side. Then on the pod, we set the pod to use this service account with service account name Wanda. This will cause the Kubernetes API server to issue a token and then mount that token onto the pod itself. Then the AWS SDK will pick this token up and use it when it does assume role with web identity when it calls AWS. Now on the AWS side, here's the IAM role we want to assume. The picture is a bit small, I apologize for that. But you can see that there's a trust policy set which allows specific OIDC provider to assume this role. And on the bottom of the config, there is a subject check which checks that the subject is set to system service account Wanda, which is the namespace and then the service account name. And also the audience that we set in the control plane settings. Now, this goes to the OIDC provider that we've configured on the IAM on itself. And this points to an S3 bucket, which is a public one. It doesn't have to be in the same account as this IAM identity provider. And let's take a look what's actually inside the S3 bucket. So there's two files. The first one is the OpenID Connect discovery data, living in well-known /OpenID configuration. It sets some stuff, for example, the issuer URL, what types of algorithms and claims it supports, and then finally the JSON web key set URL. And that is the second file, which is the JSON web key set file, or JWKS for short. And it's basically just a JSON file with a list of keys that are authorized for this provider. So any tokens signed by one of the keys present here will be considered authenticated. And it is in reality not the public key in its entirety that's here. It's a key ID that's generated based on the public key. And with all this, AWS is able to confirm that the token is valid and created by that specific cluster. And STS will provide temporary credentials back to the pod, which allow it to act as the Wanda role in AWS. And then it reaches the Wanda production bucket happily. Next, we'll cover some of the design choices made while implementing this, and I'll be handing it to Nilanjan for this.
Thank you, Erik. Before I go further, do you have any questions, anybody? Or everyone understand every line of it? Absolutely. Okay. The second one it is. Before going deep, I'll zoom out a bit from here. How many of you are running EKS today? And how many of you are using IRSA in EKS? IAM role per service account. Okay. That's one. Yeah, so this technology is something not we invented. It's the pieces are there, but what we did is to make it use for us. There are some articles in the internet, but not much of a documentation. And yeah, there are some challenges that we faced. We'll go through that now. Well, this is our infrastructure, very simple infrastructure. We have on-premise Kubernetes, and it uses IAM user to, talk to Amazon. And a bit more simpler than this is this one. So if you see here, we have the same namespaces in two different clusters. So actually what we do, we run multiple production and development clusters. Let's talk about only the production here, because we don't do multi-clustering in development. In production clusters, a service can run in multiple of any of those clusters that you want, and they should have the same level of access to AWS and other things. So if you just superimpose these two pictures in mind, this is what we do. So let's talk about a bit about our operational model. As I already mentioned, we use identical clusters per environment. By identical, I mean like configuration, capacity, and then the application teams, they are the owners of their manifests. So we don't write their manifest, they maintain their manifest, and they can do whatever they want there, sometimes causing problems for us. Our goal as a platform team is to provide them with the tools they need so that they can do their stuff without our intervention. And this is one of the reasons for the next design choice, for the first design choice I am going to present. Okay. So if you see, for example, the Wanda is running in cluster A and cluster B and maybe some other clusters. So how we can deal with this situation in two ways. One, we can have cluster specific IAM roles that only trust that cluster, or we can have a single IAM role that trusts all the clusters. Can anybody tell me which one you would do?
IAM role per part. Actually per service.
Yeah, I mean, this IAM role per service per cluster. Sorry, thank you for correcting me. Okay, so anybody can tell me which one you would do in your environment?
Actually, we have something at the moment in the same architecture. So we have OIDC, we've been using KIAM, Kubernetes IAM, then we've moved to IRC, and then to Cloud Identity, which is quite a new version of this kind of integration. The thing in here is the best one, in my opinion, is to use IAM per application, because, for example, some of the applications want to talk to a specific service, some of those we don't want to give the access to them. So definitely providing an access for whole cluster is not be something secure.
Yes, I'm sorry for the confusion here. So what I meant is like those IAM roles are for that service, but it trusts only that cluster.
Okay.
So every IAM role has your, if you remember one of the slides in Erik, he showed the trust relationship document.
Yeah.
So there you actually mention what are the federated OIDC providers you are trusting for that IAM role. So these IAM roles A, B, C, they are for a particular service, but there are two ways to do this. Whether we can create a IAM role per cluster for that service, or we can have a single IAM role that trusts all the clusters. We chose the second one. The reason is, remember I said self-service model. So we don't know if tomorrow some developer wakes up and thinks cluster B is not good, we need to move to cluster C, and they move it and they don't get access because there is no IAM role created for them. So they need to come to us, or they need to create it, and then, the problem apart from self-service model is also create a sprawl of the roles. Like we have more than 100 services running in Smartly, and we have more than 10, probably 10-ish clusters. So that for us, it's round about 100 into 10 IAM roles just for doing this. So we choose not to do that. We create a single IAM role that trusts all the clusters. But there we face another problem when we try to do that. First, when we are configuring this, we created separate OIDC provider per cluster, and then we run out of the length of a trust relationship. So Amazon has this limit of 2048 bytes by default, and you can actually increase it to 4096. But that limit we will hit the limit at any day. So what we did, we create a single OIDC provider for all the clusters of that environment that lists all the JWKS documents for every cluster. It doesn't mean that all the clusters are using the same keys. They do use different keys, but the OIDC provider lists all of them so that AWS can authenticate that single URL, and it can, authenticate any workload running on any cluster can authenticate to AWS. Yeah, this is our first blocker that we faced, and this is the choice we made. The second part. Now, how are we, creating this JWKs is another interesting problem. If you see the top side of it, the flow says we generate the key pair and then configure the API server, and from the API server you get the JWKs, because you can get it from the URL openid/v1/JWKs. All the Kubernetes API server has that thing when you enable the OIDC. And then you upload it to S3 and create the IAM identity provider, and then IRS becomes available. But there is a problem with this thing. It works for a new cluster where nothing is running, but for an existing cluster, some point of time we need to rotate the keys. Somebody will steal it, or because of some security reasons we need to rotate it. And that flow actually doesn't work when you rotate it, because as soon as we put that key in the API server, all the new service account tokens will be signed with that key, and because that is not present in the OIDC bucket, AWS will not authenticate those requests. So that will be an outage. So what we did is, we built the same JWKs as Kubernetes would do outside of Kubernetes. And then we upload it to S3, first make the AWS side ready, and then we configure the API server. So when let's say we are rotating the key, we are actually appending the new keys to the existing ones so that the existing one still works. And once we update the API server, we wait for the service account token lifetime. You can configure it actually. And then we delete the older key from the OIDC bucket. And there is no downtime involved. Yeah. I don't think there is anything else here. Yeah. Do you have anybody has any question? Okay, let's see if the demo works. I will just. Is it? Everybody can see this screen? Okay, I tried to mimic the thing that I showed that we are running it in multi-clusters. So these are two mini-cube clusters running on my laptop, and it's running one service with one IAM role. Okay, this naming is a bit funny, because in the internet while I was searching for this thing, everybody mentioned it's a DIY IRSA. Yeah. Okay, I'm inside one of the pods. Can everybody hear me? Okay.
Yeah, it's just yes, your place.
It's full hands on.
So let's see what are the environmental variables that are injected by. Okay, we have not talked about. There is one component actually. It's called Pod Identity Webhook. It's an open source project by Amazon. You can find it in internet. That actually reads the service account annotation and injects the volumes inside the pod. It's a admission webhook controller that does that, and these environmental variables you are seeing actually set by that. So AWS region, AWS role ARN, and AWS web identity token file. Whenever the SDK, AWS SDK sees this thing, it knows what to do. We don't need to tell it to assume role with web identity, but it will do it by itself. Let me. Okay. So we have nothing here. I'll just do a. Please work. Oh, it worked. So, yeah, you can see that I can assume the IAM role, which is called this DIY IRSA shared role. And yeah, that's it. You can see it in, I can go to the directory and you have 1 hour to steal this key. Yeah, it's just plain assume role things. Access key ID is secret access key and the session token. And let me also show you the. Oh, what? Okay. If you see at the environment, you can see the variables being set, and there are volumes that are added to it. Yeah, these are the mounts. And also, okay, I think there is a service account to it. Or is it part of the deployment probably?
It shows on the top there because of the pod appears.
Yes, you see this is the service account name. And this is the service account that we saw with the annotation. Yeah, I think that's all from my side. I hope everybody now can go back and do it yourself. Yeah, thank you.
Thank you.